The first battery was developed around the year 1800, but at that time they were first pretty big and they were not very effective. Plus, most of the applications that we use batteries for today were not even invented. But then technology progressed and moved forward, and I don't think anyone today would be able to hardly imagine what life would be like without batteries. So in today's experiment, we're going to revisit that initial idea that led to the development of the batteries that we use today and make our own. The theory behind the battery is pretty simple. We have two metals combined by an electrolyte. And electricity is generated by the flow of electrons from one metal to the other through the electrolyte. And the metal that releases electrons is being oxidized, and the metal taking up electrons is being reduced. And it's these moving electrons that is the electricity in our circuit. So to do this experiment, this is what we need.
Two metals, preferably zinc and copper, water in a beaker, table salt, a small low-energy light, a voltmeter, a piece of textile or cardboard, and some cables. Some kind of clips at the ends are definitely a bonus. First, dissolve as much of your salt as you can in some water. This is your electrolyte. Next, the metals.
What I did for the copper was I got this copper wire that you can actually use as a cable as well. And I cut it up into pieces and I just made these. For the zinc, I bought a zinc decoration heart, and I cut this up into smaller pieces like this, and this will work. You can use nails that have a zinc coating as well. It works the same way, but it's a little bit more difficult, but you can try it. All right, next step.
Cut and fold your textile to make pieces that are a couple of layers thick. If you use cardboard, you don't need it folded, just cut it to the size you want it. Soak one of the pieces in your electrolyte and place it on the zinc. Then put your copper on top. Just don't let the two metals come in contact. Now you can measure the electric current going between the two metals through the electrolyte. And then check if it's strong enough for your light.
Okay, so with the voltmeter, we can see that this unit here sends out about 0.7 or a little bit more than 0.7 volts, and the light that we have, on the other hand, needs about 1.8 volts to switch on. So what we can do is we can multiply this unit, make a couple of more, and then hook these up into a series, and that should bring the voltage up to a little bit more than 2 volts, and our light should switch on.
Just be careful not to short circuit the series. Connect copper from number 1 to zinc on number 2, and so on. This is when it's easier if you have cables with clips on the ends. Just like before, use the voltmeter to test out the series. Alright, looking good. And now the light.
Okay, there we have it, the basic principles of a battery or an electrochemical cell. And the voltage we get is basically just a measure of how readily the electrons leave one metal to go to another. But this voltage is actually different depending on the different combinations of metals we use. So I suggest you try different metals and see if you can get different results. Another cool thing is that the electrolyte we're using, water and table salt, can also be substituted with a lot of other things. For example, fruit, like a lemon for example. Try that. Okay, that's all we have for you today. Have fun.